Yeah, so if you could please write these on your paper as a try these. I wanted to remind you some rules of fractions. So as we go through statistics, you're going to notice that fractions occur quite often. It's just a thing. You're going to see fractions, unfortunately. So I just wanted to remind you how to approach a fraction when it comes to adding, subtracting, multiplying, dividing, what those rules are, if you didn't have a calculator to rely on, because there's some rules that we can learn that are pretty quick. So in statistics, there are times where we have to subtract from one. That's a very common mathematical thing to do. So whatever our denominator is, just put for the one, that would be 20 out of 20. If our denominator was a 6, put it 6 out of 6. If it was a 10, 10 out of 10. So that's a quick way to do it. And the rules of adding or subtracting fractions say that if you have common denominators, you add or subtract the tops and keep the bottom. So we know automatically right now that our bottom is going to be a 20. So 20 minus 14 is 6. Now, we also want any fractional stuff we have to be reduced as much as possible. So you always look for, is there a common factor that is divisible of something on top and on bottom? So what's a number that goes into both 6 and also into 20? 2. So we can divide both top and bottom by 2. So I want that simplified version, okay? So I want that simplified version. So I want a final answer to be 3/10. I don't really want decimals unless it asks for it. I don't really want a fraction that isn't reduced. So get in the habit of reducing your fraction as much as possible. Okay. Everybody good with number 6? Yes, write this down for me. This is kind of like your try these. You will turn these into me at the end of class today. Okay, so there's number 6. Now let's look at number 7 and let's kind of look at the difference. The difference between number 6 and number 7 is we don't have a 1 there, and we just have fractions with unlike denominators. So we can think of a number that both 8 and 6 will go into. You can always do 8 times 6. So 48 is always an option. But there are times you might recall from back in the day when you were taking just, traditional math somewhere along the line, 7th or 8th grade, they would talk about the least common denominator. Now that's preferable, but not essential. So if you decide to use 48, it'll work. It doesn't hurt anything. But can anybody think of a number that both 8 and 6 will go into that's smaller than 48? 24. 24 is the one you want. Yep. Okay. Yeah. So 24 is a number that both 8 and 6 will go into. So this is what you think. So how many times does 8 divide into 24? 3. So you're going to put a 3 on the top and bottom next to the 8. How many times does 6 go into 24? 4. So you're going to put a 4 next to the 6. Okay. Now, if you did it right, if you approached it right, we should be able to just multiply. So we would get 9 over 24 plus 20 over 24. And we get to use the rule from problem number 1. If the denominators are alike, we keep the denominator. We add or subtract the top. 9 plus 20 is 29. Now, mathematically speaking, if you take an algebra class someday, a college algebra course, oh, it should be 24, I'm sorry. What's great about an algebra course, 29 over 24 is a great way to just leave it. It doesn't usually help to put it into that mixed number form. It's not a bad idea to know 24 goes into 29 one time with a little bit left over. But for algebraic purposes, 29 over 24 is a good place to stop. Because 29 cannot reduce. It's a prime number. 24, they don't have anything in common. Leave it. That's your result. Any questions how we did number 7? Yeah, you could put this as a mixed number, 1 and 5 over 24. For our purposes, that's not super helpful.
Would you want that on the final?
No, you can leave it 29%. I always tell my algebra students, my calculus students, usually mixed numbers are only helpful if maybe you're going to graph something, because you'll need that it's 1 point whatever. But you can even throw that into a calculator. Okay, now let's continue the process. I want you on your paper to try number 8 and number 9. This is chapter 11. Try number 8 and number 9 on your own, on your paper, but I would like to show you in a minute. You do have to get common denominators. I will show you 8 and 9 in a minute, but try it yourself. I've given you some hints if you're a little bit stuck. That is not the only way that I've shown you. There's more than one way to do them. That is using a least common multiple. You can use higher numbers. But I've given you some hints if you're a little bit stuck. And then I'll do 8 and 9 for you just in a moment. Okay, so everybody look up at number 8. I would suggest turning them into 15s. It is an option if one of your numbers goes into the other number evenly, that you can use that as your least common denominator. So if we turn this one into 15ths, we can then subtract. Remember, you can't add or subtract fractions unless they have the same denominator. So that would be 8 over 15 minus 6 over 15. Now recall that when you're adding and subtracting fractions, you're going to keep the denominator. You're only adding and subtracting the tops. The 15th tells you kind of the size of the piece. The top of the fraction tells you how many you have. I have 8 15ths. I have 6 15ths. 8 minus 6 is 2. Okay. Now on the second one, number 9, we get 5 over 60 minus 6 over 60. Now here's the first time that we've come across one that has a negative answer. Okay. Oh, that's a plus. We don't have a negative answer. 5 plus 6 is 11 over 60. If you got, say, 22 over 120, that's okay. But remember, both the top and the bottom are divisible by 2. So you could reduce it down one step. So if you get an answer different from me, you just might not have reduced it. And it's equivalent. It is the same answer. It is helpful sometimes then to reduce it down. So if you didn't get the answers I got, you probably just used a higher denominator. It should reduce down to match my answer one way or the other. Okay, any questions about 6 through 9? We good about adding and subtracting fractions. Common denominator, add or subtract the top. That's the main idea, okay? Now, that's a lot different than multiplying and dividing fractions. So let's talk about the rules for multiplication and division. To multiply fractions, Here's another reason that mixed numbers aren't super helpful. We can't use mixed numbers. So let's do number 10, and then we'll talk about what we have to fix on number 11, okay? Now, here's what people forget for number 10. You just multiply the tops with the tops, the bottoms with the bottoms. Some people think they have to do some kind of cross multiplication kind of stuff. No. Tops with tops, bottoms with bottoms. 1 times 3 is 3. 2 times 7 is 14. You can sometimes do a cross cancel, but you can't do a cross multiplication. That's something different. That's in proportions, but not in multiplication. Tops with tops, bottoms with bottoms, reduce if you can. Okay? So look at how 11, we don't have a distinct top or bottom. So here's what we have to do. We're going to do a trick. We're going to take this mixed number and we're going to change it. Amir, you know how to do that? You want to tell us what to do? Exactly. 2 times 3. He said he multiplies those. He got that 6 and add the 1. Perfect. So we're going to do that first. That's going to become 7 over 3 over 1 over 4. So it's going to be the same idea now. We're going to multiply tops with tops, bottoms with bottoms. 7 times 1, 4 times 3. Reduce if you can. Can we reduce? No, we cannot. So you're done. Okay? So for multiplication of fractions, you multiply tops with tops, bottoms with bottoms. You can cancel across the top. You can cancel sometimes, but you can wait and cancel at the very end. 7 and 12 have nothing in common. You're done. Okay? Everybody good with 10 and 11? Now, multiplication is different than division. Slightly different extra rule in division. Division, we're going to turn into a multiplication problem. So the strategy off the top for a division is similar in a way to a multiplication. But this is what some people, when you're back in elementary school, they're going to say keep, change, flip. Keep, change, flip. Okay, now, that's way back in the day. Keep, change, flip. But here's the way it goes. To divide by a fraction is the same as multiplying by its reciprocal. A reciprocal of a fraction is the flip of that fraction. So to divide by a fraction is the same as multiplying by its reciprocal. So if I want to change that to its reciprocal, I make it 2 over 1. I am dividing by the reciprocal of the thing after the division symbol. So to divide by a fraction is the same as multiplying by its reciprocal. Now we know what to do for a multiplication problem, right? We multiply tops with tops and bottoms with bottoms. So it becomes 8 over 5. Now, if you want to make that into a mixed number, go for it. Does it matter to me? No. I'm a calculus teacher. I know that changing that is not normally super helpful. If you do, I don't care. Great. Don't waste your time if you don't have to. Sometimes if it would be a monetary thing, or if it'd be something that there was a real life application, that, like that one right there is 1.6. Knowing that might be helpful. For us, depends. Okay, so we're going to do the keep, change, flip. But here's the problem. Think about what Amir told us to do for that other problem. We have to do that for this first. So we're going to multiply, add. So it's going to be 15 plus 1. That's 16. That's what we keep, 16 thirds. Keep, change, flip. So we keep the 16 thirds, we change it to a multiplication, and we flip the thing after that sign. Okay, keep, change, flip. Keep the original number, but in fractional form. Change the sign, flip the thing afterwards. Okay, and now what are you going to do? You're going to multiply tops with tops, bottoms with bottoms. We're going to get 64 over 3. 64 has nothing in common with 3. You're good just leaving it. I don't care about trying to make it a mixed number. If you want to, that's like 21 and 1/3. Go for it. It's not helpful. Leave it what it is. Okay? Everybody good with multiplication and division now that we have seen a few problems? Good? Okay. The percent problems. They're not going anywhere. For probability and things like that, percentage problems come up again. When are you going to see percentage problems again? On the final. They're going to be there. But guess what? We know how to do 14 and 15. Do you remember that formula is over of equals percent over 100? Remember that? Is over of equals percent over 100. I want you to try 14 and 15, please. Try 14 and 15 at this time using our is over of equals percent over 100. So if you guys could please try 14 and 15. Try is over of equals percent over 100. Try those two. I will show you, you know how that goes. But I want you to try 14 and 15, please. See that we're getting the same sort of stuff. Is over of equals percent over 100 is what you want to use. Okay. Now, I'm going to let you keep going, but could anybody share with us how they set up number 14? Just the setup. You want to share? Okay. What'd you get? What's your setup? Now, the percentage is always over 100. What's by the of? What number comes right after the of? That 150. So that's going to go here. Our is, what number is? Our is missing. So that's going to be our x. And remember, to solve that, you're going to multiply the 7 times the 150 and then divide by the number you haven't used. You're going to divide by the 100. So that's the setup for number 14. What's missing in 15? The is over of or the percent? What's missing in 15? The is, the of, or the percent? The of, right? So that's our x. Try to set up 15, and I'll show you the true setup in just a second. Try the setup for 15. So I've shown you the two setups up here on the board. Check your setup. Did you set up the right thing? Is over of equals percent over 100. If they say of what number, your of is missing. If they say is what number, your is missing. That's kind of a way to kind of check your work. So I've set up those there for you. Now, remember, you're always going to cross the two numbers that are crossing each other. You're going to end up dividing by the one you haven't used. Multiply by the two numbers that are crossing each other. Divide by the one you haven't used. So give those a shot, and then we'll talk about the answers. Is over of percent over 100. Didn't go anywhere. Okay, let me pull up a calculator here and we can do a little math. Okay, Anybody get an answer for 14? Anybody get an answer they want to share for 14? You guys said that way. 10.5, is that what you guys got? Okay. So the answer to this one, thank you, is 10.5. And then the other one, you should get 50. Is the another number 50? Okay. So that is something we will revisit, you know. Okay, let's take a look at 17 together. It says 20% of the water in a large aquarium should be changed weekly. How much? Oh, I skipped 16. I'm sorry, all my scribbles there. Let's do 16. A $24 item receives a price increase of 12%. How much was the price increase? To calculate 12% of something, you're going to multiply by 12%. So 24 times 12 over 100 is one way to do it. 24 times 12 hitting a percent key is one way to do it. 24 times 12 over 100 or times 0.12 is also acceptable. I tend to usually do 24 times 0.12. Now, be careful how those problems are worded. If those problems say, how much is the price increase? You would put the answer $2.88. And that's what they asked. How much was the price increase? It's $2.88. If they ask, though, how much is the new price? What would be the extra step we would have to take? We would add that back on. Okay, so watch how they ask the question. If it's a price increase, you add it back on. If it's like a discount, you would subtract it off. Okay, now let's go to 17. 20% of the water in an aquarium should be changed weekly. How much water should be changed each week if the aquarium holds 65 gallons? Well, just like we found out what 12% was in the last problem, we just have to figure out what is 20%. So we're going to do 65 times 20%, or 65 times 0.20. I think it's 13, but let's just check. 65 times 0.20, yeah, it's 13. I'll say that again, I'm sorry. Oh, you could do it like that, yeah. So it's 13 gallons for that you would have to change weekly, okay? One other thing that's going to be on our final exam, measures of central tendency. Do you remember how to find the mean, median, and mode? Okay, we're not going to do all of these. Cross them out. We're only going to do 18 before we move on, okay? So on the final exam in a week and a half, is that 2 weeks? I don't know. It's on a Monday. Week and a half? Oh my gosh. Anyway, I know. At first I was really panicked because I'm like, oh, but I'm ready. So anyway, 18, mean, median, and mode. Mean, average them. Median, put them in order. Which one's in the middle? Remember, median, middle of the road is the median. Mode, which one occurs most often? Okay, so take a second, try to find the mean, median, and mode of those. I'll show you my work here momentarily. See if you remember. That will be something that will be on our final exam. Mean, median, and mode. So you may recall, for the mean, you're going to add them up, divide by how many are on the list. There are 5 on our list. They add up to 25. 25 divided by 5 is 5. So the average is 5. The median, remember, is that middle value. I always tend to put them in order. If there are an odd number of things on our list, it's just what's smack dab in the middle. So the 4 is sitting in the middle spot. So that's our median. Our mode is the number on the list that occurs most often. If there isn't one that occurs most often, there may not be a mode. You might have to write none. But this one does have that 4 repeated twice. So that's why 4 is our mode, okay? So hopefully that reminded you of those things we did a few weeks ago, a few months ago, something like that, okay? Any questions about mean, median, and mode? Remember those things? Okay. Okay. So chapter 11 in our book is about statistics. It's about probability and statistics. So we're just going to touch upon those items. One, it'll help you if you ever take a statistics class in your future. It'll also, that's what chapter 11 is all about. Okay. So the first thing we're going to talk about is something about, it's called the counting principle. Okay. So I think this example will help us really kind of figure out. Okay. So you got this menu. Okay. And on the menu, you have a choice of an entree, a drink, and a side dish. And the question is, how many meal choices do you have? How many different plans could you plan out? How many meal choices are there? Now, this is what's interesting about a problem like this. It's just a multiplication. It is much easier than students want to make it. You're just thinking how many main dishes times how many drinks times how many sides times how many was that the only thing they had? 3 things? Yeah, you should be writing these down. Well, these ones, I mean, it's up to you as what you write and what you don't write, because this is more of your notes. We will have some problems like this, on our final. It does include some of chapter 11. Okay. So if you want to calculate how many there were 3 different entrees, there were 4 drinks, and there were 3 sides. So there are 36 ways to choose your lunch. Okay. So if you see questions like that occasionally, and they'll say, how many different choices do you have when you pick your lunch? And it is just a simple, how many different things do you have to choose from? So I had 3 mains, 4 drinks, and 3 sides. There are 36 different orders. And there's also, you can make what's called a tree. You could put pizza, chicken, beef, and then you could put underneath that like a little tree that says, oh, I could have chose what were the drinks? Milk, juice, tea, or what is that? Punch. Okay, so you would have 4 branches coming out there, and when it's all said and done, you'd have 36 branches. Now, writing that all out isn't necessary, but that's kind of a way you can visualize it if you had the urge to write all those out. Okay, let's look at this one. You'll see ones like this a lot. They'll talk about license plates, they'll talk about cards, they'll talk about dice. Those are very common in probability when you're first learning about it. Okay, so let's look at example 1B. It says in Utah, a license plate consists of 3 digits followed by 3 letters. The letters I, O, and Q are not used, and each digit or letter may be used more than once. How many different license plates are possible? Okay, so if we think about 3 letters, How many different letters are there if we take out I, O, and Q? We got 23. So we're using 3 letters in each location of the letter spot. How many digits are there if we use each digit of our number system? Well, no, they're not talking about in each spot, it'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the other spot, there'll be 0, 1 through 10. So they assume it's 0 through, not through 10, 0 through 9. There are 10 possibilities. So in that spot, 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 gives you 10 things. So there's 10 possibilities in each spot. So that would be times 10 times 10 times 10. Now, only if they gave us a non-restricted, if it could have 25 digits, would we think if there's no restrictions on how long it would be, that's when the infinite comes into place. But if you do that, there are 12,167,000 different license plates that state uses. What does Ohio use now? Is it 3 letters and 4, or 3 letters and 4 numbers? Is it 3 and 3 still? I'm trying to think if mine has 4.
When I sign people into the system at housing, I look at their ID number for their driver's license, and it's 2 letters and 6.
Oh yeah, the driver's license number is different. Okay. Yeah. Now, that is how many different, this is called a combination. So put a little note to yourself. That is a combination, okay? But in statistics, they use a word you'll sometimes come across called a permutation. And a permutation is when order is important. So, coming in first, second, and third in a race is different from picking out any 3 people from the race. So when order is important, you get mathematically a little something different we have to do. It is called a permutation, okay? So I am going to use that term, and I'm going to show you how to mathematically deal with a permutation. So a permutation, when the order is important, do you see here how there are different combinations? This one, C came in first, C came in second, C came in third. And then here, C came in first, C came in second, C came in third. But look where A and B, see how it's the A and B switched around here? Here the A and B switched around. Here the A and B switched around. So that is different from saying how many different lunches I can get, because a piece of pizza and some coleslaw and a punch drink is the same as a punch drink and a pizza and a coleslaw. You know what I mean? Order is not important in that. But in a permutation, we are going to have to care about the order. So the math is going to be a little bit different because of the fact we are going to have to consider what place did they get in the race? What place did they get in the whatever it happens to be? Okay, so order matters for something called a permutation, and I want to give you some formulas so that you'll know those. Okay. So one of the things that you're gonna see mathematically when it comes to permutations and even combinations, I'm going to show you some formulas there, is something called a factorial. And it uses this notation. Some calculators have that button. It's going to show an exclamation after the N or whatever it happens to be. That exclamation mark means factorial, and it has to be a whole number. So an example would be 6 factorial. 6 factorial is going to be 6 times 5 times 4 times 3 times 2 times 1. Now, mathematically, how do we write factorial? Here, let me show you. You'll do, it's going to be n times n minus 1 times n minus 2. You keep doing that pattern until you get to the number 1. Okay? So mathematically, that's how we write that. But that notation, some calculators have it, some calculators don't. I'm going to show you a way to deal with that notation so that you don't have to worry if your calculator doesn't have that button. If that was 16 factorial, I'm not going to have you write or put into your calculator 16 times, 15 times, 14 times, 13 times, 12, all the way down to 1. That's a lot. But most of the time, there's a way that we can do some figuring, okay? So that's just some notation so I can give you some formulas. So make sure you have that formula written down for n factorial, and then I'm going to show you some formulas here in a second. So everybody have those formulas written down? Okay. So this is a permutation right here. It's going to use this notation. And it is if we have n items to choose from, and we are taking r of them at a time. Okay, here's what I mean by that. Now remember, in a permutation, the order matters. So make yourself a note. Order matters. Okay, so you read this. It is the permutation of n choose r. Okay, I'm going to read that. The permutation of n choose r, meaning I had n things to pick from, and I'm choosing r. So if I have 5 choose 3, the permutation of 5 choose 3. That means, as a quick example, 5 people were running a race, and I choose the first place, the second place, and the third place. I choose the places. And the question is how many different ways can that race come out as the winner, the second place, and the third place? That's all that means, okay? So you have to know that formula, and I'm going to show you an example of that formula in just a minute, but make sure you write that formula down. That is a formula we are going to use. So I want you to see that formula so that we can use the formula. And I'm going to show you an example in a minute. Okay, so make sure you write down that formula. Make sure you write down the words of what it means. I'm going to show you just the notation, how to put that into your calculator, or you can kind of do some of it in your brain. And then I'm going to show you a word problem that looks similar. We can write that notation. Okay, so what does that, the 5 in front, the 3 in back on a P? Well, that's going to be 5 factorial over 5 minus 3 factorial. Okay, now what the heck do we do with that? Well, 5 minus 3 is 2, so make that a 2. Now, let's mathematically think about what this is, okay? 5 factorial, and because I made them small enough numbers, we're going to be able to write it out, and it'll make more sense. Isn't that 5 times 4 times 3 times 2 times 1? 2 factorial is just 2 times 1. Do you see how those ones cancel? What's left? 5 times 4 times 3. 5 times 4 times 3 is 60. So if 5 people start a race, and we have a runner amongst our midst here, 5 people start a race, there are 60 different ways that we could find first, second, and third place. There are 60 different possible ways that that race could turn out. If we knew nothing about the racers, if we knew nothing about who was the best, if we thought about how the outcome could occur, there are 60 different possibilities for the first and second and third place to come out. Okay? That's what that means. Now, let's wrap this around some words by finding a permutation that matches our 2A example. Okay, so let's look at this question and let's talk about this example. It says, how many ways can a club select a president, a vice president, and a secretary from a group of 5 people? Now, the reason order matters here is because we are giving each one of these people a distinct designation. Thank you. A distinct, position in the group. Okay. So a position in the group could be first, second, third, can be vice president, president, secretary. Okay. So they have that designation. So what that means is we had 5 people. We are picking 3 to fill those positions. That is 5 factorial over 2 factorial, which we already did, is 60. So the word problem, by recognizing it's a permutation, we got a formula, and we can plop it into the formula. So there are 60 different ways we can fill those positions. Now, let me show you mathematically a different way of thinking about it. And sometimes when I forget the formula, I can think about this. There are 5 people in the room. I'm going to pick president, okay? And Mike is going to be our president, okay? So now there's not 5 people to pick from anymore, are there? Now there's 4 people to pick from for vice president, okay? So Paige gets vice president. So now Paige is vice president. So there were 4 people from that time. So when Micah was picked, there were 5. When Paige was picked, there was 4. And now we need to pick, there's only 3 left that we get to pick the secretary. So Chet is the secretary. So now we've got, initially we had 5, and then we had 4, and then we had 3. Wasn't it 5 times 4 times 3, which is 60? So if it's a small, you can do that with anything. If you're only picking the first 3, if you're only picking the first 5, you can do that thinking, and it will get you the same result. A permutation is kind of a nicer one than combinations. Combinations can be a little tricky mathematically. I always have to think about, in a combination, the orders don't matter. So my pizza, my punch, and my coleslaw is the same as my coleslaw and my pizza and my punch. So how do I take that out of there? So there's a little more mathematics for a combination. Permutations are kind of more instinctual as to what you do. Let's look at one more. It says an art gallery has 9 fine art photographs, and they are going to display them from left to right along a wall. In how many different ways can the gallery select and display the 4 photographs? So here's where you have to recognize that each one of those is a distinct position, okay? So we have 9 photographs to pick from, and we want 4 of them to be in the first position, the second position, the third position, and the fourth position. The order matters for how it looks. That tells us we're going to use permutations. So mathematically, we have 9 to pick from, and we are picking 4. That's the permutation. So, are we picking 4? Yeah, okay. So, that is going to be 9 factorial over 9 minus 4 factorial, or 9 factorial over 5 factorial. That sure doesn't look like a 5, does it? Now, Mathematically, let's think about what we have to do. Think about the fact this is 9 times 8 times 7 times 6 times 5 times 4 times, that is not a 3. 3 and 2 and 1, right? 5 factorial is 5 times 4 times 3 times 2 times 1. Mathematically speaking, that's division. We can divide off the 5 and the 4 and the 3 and the 2 and the 1. We are left with 9876. Now, same thing we were talking about if there are 5 people in the room and we're picking vice president, secretary, president. Same idea. When we first have those pictures laid out on the table, we got 9 of them to pick to go in the first spot. Now we've picked that first spot, so now there's 8 of them for the second spot. We've picked that one, now there's 7 of them for the third spot. Now we picked one, so there's 6 of them left for the last spot. So it does become 9 times 8 times 7 times 6. Did anybody do 9 times 8 times 7 times 6? What is it? 3024? Thank you. Okay, so be careful. You have to know and recognize if we are arranging something in order or if the order doesn't matter. There's a difference, okay? So a combination is a grouping of items where the order does not matter. The order does not matter. So ABC in a permutation is different than ACB. But in a combination, an A with a B with a C is all the same. So the combination has less things because those repeated pairs or triples or whatever we have to throw out. So the formula looks a little different. So let's talk about the formula for a combination. Here's the formula. Order doesn't matter. In a combination, order doesn't matter. We had n items. We are picking 3 of those items. Order doesn't matter. We have n items. We are picking 3 of them. Okay? Order doesn't matter. In a combination, it's important to know the difference. It will help you when you go to decide which formula to use. Look at what's happening here. Do you notice this is the original formula? What are you doing? You're dividing off by that r factorial. Why? That's dividing off where the repeats are. That's dividing off that ABC is the same as BAC. Order doesn't matter, so ABC and BAC are the same thing. Okay, so it's the same it's the same formula right here. You're just dividing off those extra pieces. Okay, so it's important to have both of these formulas written down, and then I'm going to show you, and I'm going to show you where this comes across with probability eventually. I think we'll get there. Okay, everybody have that formula written down? Okay, so now gotta find where my slide is here. Let's look at a picture and look at those kitties. I'm a sucker for a kitty cat. Okay, so Katie's going to go into this place to adopt a kitten. There's a litter of 11. Oh my goodness, that's horrible to have 11 kittens. Anyway, how many ways can she choose a group of 3 kittens? Now, if you choose kitten George and kitten Cece and kitten Smokey from the room, if you have those 3 cats, those are 3 of my cats. Anyway, if you
2 normal names to 1, that's very interesting.
Yeah.
Position.
We have George and Cece and Smokey. And I have Ratchet and Clank. It's a long story. Anyway.
Oh, Ratchet and Clank.
I do. Okay. Anyway, so you're in this room. Now, if you have George and Cece and Smokey in your basket to take home, is that any different from having Cece and Smokey and George? Order doesn't matter, okay? So that's the first thing you want to recognize here. Order doesn't matter. So that means we're going to use the combination formula. How many kittens were there to pick from? 11. How many are we taking home? 3. So that's the formula we want to use, okay? So it's going to be 11 factorial, and then it's going to be 3 factorial, and then 11 minus 3. Now, my suggestion to you, always do the parenthesis first. 11 minus 3 is 8. You know you got the first step of the formula right if those two numbers add up to your top. Does 3 and 8 add up to 11? Yes. They'll always happen. If it doesn't, you subtracted wrong, okay? Or you put the numbers in the formula wrong. But those two numbers on the bottom in that first step of the simplification should always, 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 always add up to the top. Okay, next. Now, I'm going to write it kind of in different colors so we can kind of follow along. 11 factorial. I know it's a lot to write, and eventually you'll see the pattern. You might not have to write it all, but let me show you. That's 11 times 10 times 9. What's going to happen to the 8 and the 7 and the 6 and the 5 and the 4 and the 3 and the 2 and the 1? It's going to cancel out because isn't there an 8 factorial down in the bottom? You don't even have to write them if you recognize that. These are going to cancel out. Now, we do have that 3 and that 2 and that 1, so don't forget about those. Does that make sense what happened? Because that 8 factorial, and I always think of the bigger number on the bottom, cancel all those out. So the 8, the 7, the 6, the 5, the 4, the 3, the 2, and the 1, those are all going to cancel out. If you did it right, here's another check. You always get a whole number. So there better be a way to cancel out the 3. There better be a way to cancel out the 2. Does dividing by 1 hurt anything or change anything? No. So let's find the way to cancel out the 3 and the 2 and the 1. What on the top that's left? Does the 3 cancel out? The 9. Okay, so let's do that. So the 3 cancels out the 9. 3 goes into 9 3 times. There better be a spot that's divisible by 2. What is left that is divisible by 2? The 10. 2 goes into 10 5 times. Okay, so the only thing left on top really is 11 and 5 and 3. Now, if you want to pull out a calculator too, 11 times 5 times 3, that's just 55 times 3 or 165. Okay. So I have 11 kittens in that room. If I go to pick 3 to bring home with me, I have 165 different ways to pick out my 3. Maybe if you don't get them fixed, and then, but everybody see how I did that canceling? Everybody see how I did that canceling? Do you have to? No. If you have a calculator that has a factorial button, like when you turn your phone to the side, if it has a factorial button, some calculators do. You can put 11 factorial divided by 3 factorial divided by 8 factorial into your calculator. You'll get 165. So if you have a calculator that has those buttons, practice that, because on the final you'll be able to use a calculator. But if you don't have, I'll have the red button, the red calculators. There's a permutation section And I'm pretty sure there's factorial. And if I can remember to bring some, I'll get you.
So you could also just
There's a way to do it.
you could also just regular.
So that's our kitten problem. I saw that one. I'm like, ooh, that's a good one. Okay. So try these. We're going to do these right now on paper, problems 1 through 8. Now, what's really great, do you see how it says see example 3 and see example 2 and see example 1? That tells you you can go back to those problems we had done and you can use those kind of as a resource, okay? But so if you have your computer open so you can see it better, right now, we're going to do problems 1 through 8. So, okay. Now, before we move on to the homework, I would like to go over each of these problems so that you make sure that you're doing them correctly, because then in class today, you need to work on the homework before you can leave. Now, if you finish the homework, as soon as you finish the homework, you can hand it to me and walk away, but not until then. So normally I wait for your homework, you know, Saturday, whatever. But now homework is going to be done before you walk out. We got class time. We're going to use it. Okay. So let's go over these 8 problems. The first one, when you are putting a combination lock in, it is important that you put it in the correct order, right? If the combination is 1, 2, 3, if I put in 2, 3, 1, it's not going to fly. So problem number 1, the order is important. It's a permutation. Okay. Number 2, that is just a simple, I had 3 things and 3 things and 2 things. There are 18 different things to choose from. Number 3 is 9 times 25. Is that 225? Okay. Number 4. Now, 4, 5, and 6. 4, 5, and 6. The order in which it happens matters. So that is why we have to use the permutation formula. When the order matters, it is a permutation. So this is going to be 7 factorial over 5 factorial, because you would do 7 minus 2, which is 5. And so it ends up being, when it cancels out, 7 times 6, or 42. P ends up being 12 factorial over 9 factorial, which is 12 times 11 times 10, which is 1320. Is that, no, 1320? Yeah. Is that good? Number 6, that's going to be 6 factorial over 3 factorial, which is 6 times 5 times 4, which is 120. Now, those are permutations, okay? Now, for 7 and 8, the 4 students that go to the library, it doesn't matter the order in which Mary and John and Sue and Tim go to the library. The 4 of them are going no particular order. So that tells us it's a combination. So that's going to be 21 factorial over 4 factorial, 17 factorial, which is going to be 21 times 20 times 19 times 18 divided by 4 and 3 and 2 and 1. I canceled some stuff out. I canceled 17 and lower. And then the rest should cancel out somewhere along the line. 3 times 2 is 6, goes into 18 3 times. 4 goes into 25 times. And if we do what's left on a calculator, it's going to be a pretty darn big number. Sounds right to me, but let me just kind of, 21 times 5 times 19 times 3. Yeah, 5985. Yep. And then finally here, the order matters. So it's 5 factorial over 2 factorial, 3 factorial. That's 5 times 4. The 3, 2, 1 cancel, and there's a 2 and a 1 left. So that's 10. Okay. Right. Oh, look, no, look how easy those are. They've just set them up for you. There's no words. Yeah. No. Okay. So before you walk out of this room, I want your homework. I don't want it Saturday or Friday. I want it now. We got class time. So if you have your homework done, if you were a person that looked at this ahead of time and had it done, hand it to me and walk away.
Time I would have done it ahead of time, but
If
this week.
You aren't a person that doesn't have it done, then you don't leave this room till you hand me the try these and this homework. And then you get the heck out of here. And then you don't have anything to do for the week. Okay?